Okay, here we are, 2.1a. Name of this section is called Algebraic and Graphical Solution of Linear Equations. And in the last chapter, we talked about linear equations. And linear equations, if you remember, do not have an x or a y in the denominator, do not have exponents on the x or the y, except for the assumed 1, which is on each of these x's here, and therefore making that a linear equation. Now what we're going to do is we're going to learn how to solve these algebraically, and then we're going to learn how to solve these graphically. Now algebraic solutions are the ones that are going to be the most used because they're the most accurate, although the graphical solutions gives you a picture of what the solution looks like, and sometimes visually that information is more helpful to what you're doing if you're not expecting to get an exact answer. Okay, so bottom of page 92, top of page 93, I would write down those 5 steps for solving a linear equation in one variable. One variable means we only have one variable in x. Even though it appears twice, there's only one letter. Okay, so what we're going to do here, first of all, is we're going to get rid of the fractions. It makes life so much easier when you get rid of the fractions. And this method of getting rid of the fractions only works on an equation, only works when there's an equal sign. If there is not an equal sign, okay, if I just have something like 2x plus 1/3, that is not an equation because there's no equal sign. Okay, all that is a statement. Okay, so different way of solving that. In fact, you don't even solve it, you just simplify that. All right, so when you do have a fraction, what you're going to do is you're going to find the least common denominator. Okay, and in this particular one, it's 12. And what we're going to do is we're going to multiply the entire thing by 12. So we're going to multiply the 12 times this fraction, the 12 times this fraction, and the 12 times 1. Okay, so let's go ahead and do that. I'm going to go ahead and rewrite this so that you don't forget to multiply that 12 times every part of the equation. So that being the case, that cancels, and we have a 3. We distribute. Notice there's no fraction. 12 over 3 is 4. And 12 times 1 is 12. And now we can just use simple algebra. You know, move the 9 over, move the 4 over, divide by the coefficient, and you get the answer. Well, let's just go ahead and do it on this first one. Oops. And x equals 21 over 2. So that's our solution there. So the nice thing about it is being able to get rid of that doggone fraction. Okay, so that was example 1, letter A. Let's look at B. So again, here's example B, and what we're going to do, before we do anything, we're going to combine these terms right there. And we have y over 5 minus y over 4 equals 7 over 20. Okay, it just simplifies that a little bit. All right, now we're going to look for the least common denominator, the lowest number that both 5, 4, and 20 go into. In this case, it's 20, so we're going to multiply each of these terms by 20. Okay, so this is going to be 4y minus 5y equals 7. That made it a lot simpler. Minus 1y equals 7. Okay, and when we have that, I think I had mentioned it earlier, if you want to change this y to a positive, just change it to a positive. The key thing is every single term in the rest of the problem also has to be changed to its opposite. So if negative y equals 7, then positive y equals negative 7, and that's what we prefer. Okay, for C in example number 1, we're solving for x if y equals 0.72 in this equation. So we're just going to Substitute 0.72 for y, and we get, so we're going to add 2.56 to both sides, and we end up with 3.28 equals 1.312x. Divide both sides by 1.312. Those go away. 3.28 divided by 1.312, and we get 2.5. All right, so we're going to do some real-world examples here. In example 2, having to do with credit card debt, and really not much different than what we're doing now. We just have to either come up with the equation or find the correct numbers that we're going to be using. So in this particular one, example 2, they give us the equation. We again don't have to worry about where it came from. That's not what this course is about. But knowing how to use the numbers is what's important. Okay, and that's dollars. All right, so it's hard to pay off credit card, The interest paid on a $10,000 debt over 3 years is approximated by this particular formula, when the interest rate is X. So the interest rate is X. This answer, once we get done here, will tell us how much interest we had to pay on that $10,000 over a period of 3 years. Okay, so in order to do this, all we're going to have to do is solve the linear equation. Okay, and in this particular case, it says, what is the interest rate if the interest is 1637.60? Remember this, y is the amount of interest that we paid. What is the amount of interest? 1637.60. And that equals 175.393x minus 116.287. So we're going to solve for x there, and when we solve for x, that'll give us the interest rate. Okay, so not a whole ton there. So we're going to add this to both sides, and that one will go away. Okay, we're going to add that, and in this case we get 1753.887, and that equals 175.393x. Divide both sides by 175.393x, and that will give us 9.9998, or approximately 10% interest. Okay, so that is example 2. That's using more of a real-life experience to solve a linear equation. All right, so when we continue on, we've got a stock market. For a period of time, a man is very successful, with his value growing to 100,000. However, the stock drops rapidly until its value has been reduced by 40%. If it's been reduced by 40%, that means he has 60% left. What percent increase will have to occur before the latest value returns to 100,000? All right, so probably the hardest thing about these story problems is understanding what they mean. So let's say that he put in $10. Okay, let's just try to make this problem easier as far as what they're asking for, and then we'll do the actual problem. He put in $10. He lost a whole bunch of money, and now he only has $6 left. We need to know what the percent increase the stock market needs to go back up to his original $10. Okay, so that's what we're looking for, except they're using 100,000, and they're saying it reduced by 40%, and so that's what makes it a little bit trickier. But if you understand what they're asking you to do, it kind of makes it easier to come up with a solution. Okay, so if he started out with $100,000 and it went down 40%. Okay, so it went down 40% of what? 40% of the 100,000 he invested, or he had. Okay, so he had 100,000. We took away 40% of that 100,000. Now we can't use 40%. You can't use that in math. You've got to change it to a decimal. So we're going to change it to 0.40 because that's the decimal equivalent to 40%. Okay, that equals $60,000. That's how much money he has left after he lost 40%. Now what we're trying to do is we're trying to figure out what the percent increase on the 60% needs to be in order for him to get his 100,000 back. So this is what it's going to look like. We have his 60,000. We're not even going to mess with that, okay? But we're going to have to add his percent increase. So we're going to have to add $60,000 times a percentage, the percentage of $60,000, add it to this 60, and that should give us 100,000. Okay? So this is what he has. He has to increase plus $60,000 times a certain percentage in order to get the 100,000. Okay. So we do our math and we get 60,000 P equals 40,000 because we subtracted that from both sides. So P equals 40,000 over 60,000, or because there's 4 zeros on top, 4 on bottom, we can just cancel those out and get 2/3. Change that to a decimal, and that'll be 66 2/3%, or around 67%, in order for him to get his $100,000 back. So it's going to have to grow 67% in order for him to get his money back. Okay, so page 95, solution zeros and x-intercepts. All right, so we're going to look at a couple different words or phrases that basically mean the same thing. If I am talking about the zeros of a function, I'm talking about where that particular graph crosses the x-axis. So if I have a graph like that, my zeros are where it crosses the x-axis, meaning my y value is going to be 0. My x value is, like on this one, is going to be a negative, well, let's say 2. This is going to be a positive 6, and this will be like a positive 10. But the y values are going to be 0. We didn't go up or down. So those are the zeros of the function where it crosses the x-axis. Okay, it's also called the x-intercept, and it's also called the real solutions to the equation. So we've got real zeros, real solutions, the x-intercept, all kinds of different phrases to basically say the same thing. So moving us to example 4, relationships among x-intercepts, zeros, and solutions. So for the function f of x, and again that f of x is basically the same thing as saying y. Okay, 13x minus 39, they want us to find f of 3. Well, all that means is you're going to put, wherever you see an x, you're going to put a 3 in its place, and that's going to give you the answer of 0. The B part says find the 0 of f of x equals 13x minus 39. Okay, so the 0 of this is what number can I put in here for x that's going to make this value 0? Because remember, that's my y. So 0 equals 13x minus 39. Okay, I'm just going to solve this. I'm going to add 39 to both sides. Divide by 13. X is 39 over 13, or 3. Okay, so same thing we did, but instead of finding f of 3, we found the zeros. All right, and part C, the x-intercept of the graph y equals 13x minus 39. Where does it cross the x-axis? Well, it has to cross when y is 0. So again, we're just going to solve this, and we end up with 3 again. So the solution to the equation, D, 13x minus 39 equals 0. Same thing. Add 39 to both sides, we get x equals 3. So all that to say, A, B, C, and D are 4 different methods of asking the same question. All right, so don't let that really confuse you or throw you off. All right, so I'm going to shut this video down and go to 2.1 B as in boy.